QA3 is not totally organic chemistry, but I've got a little bit of organic chemistry inside there. But I want you guys to look in QA3 because QA3, let me open up QA3. The one that you did in the look at the trials exam, that one is do organic chemistry one. Sometimes they could be something like this. Differentiate between acids. Differentiate between acids. So like this, 7 marks. Can you guys try this question? Test out to a certain extent, right? You can predict observation of this experiment. I'll give you guys a few minutes to try this question. Now let's go through this question. They want, remember, it's between methanoic acid, nitric acid, and sulfuric acid. This one, right, will be no change. No change. This one is purple, potassium, permanganate, decolorizes. This one actually also occurred in your, I think, exam or the exam. A lot of you was very curious. Mr. Justin, carboxylic acid reacts with sodium carbonate. For sure can never react potassium permanganate one. And yet got one time, right, a few times, right, in the paper 3, right, they're gonna put it react with sodium carbonate. as well as react with Toland's reagent of rare potassium permanganate. Okay, then you must ask, what's going on? Okay, this is in A2. In A2, you're going to learn there are only two types of carboxylic acid that can get further oxidized. Yeah, this is in A2. The first one is methanoic acid. The second one is ethane dioic acid. So therefore, it will look something like this. H O H H C O O H. Then this one there, the other one there is this one. HOOC COOH. Both of them there, they will if reacts with potassium permanganate, will form carbon dioxide and water. That's what happens. They got oxidized to form carbon dioxide and water. That's why the acid can decolorize both potassium permanganate. They may ask, so how are we supposed to know that? Don't ask me how, because this particular knowledge, right, is supposed to be taught in A2. This particular knowledge is supposed to be taught in A2. You can go check the syllabus. You're supposed to know this, but it's in A2, not AS right now. So I also don't know why they're going to put this in paper 3. So I only can tell you that if you ever see an organic acid that can react with sodium carbonate and react with zinc, know that there are 1 or 2 acids that can do this. This one there is no reaction or no change. Sorry, no change. No change. However, this one there got a reaction. What's happening right here, right, is that solution turns blue. Okay. What's happening there is actually this is redox. Do take note. Copper is too unreactive to react with acid. Therefore, this is a redox where copper is actually now reacting with copper 2 plus, reacting with NO3 minus nitrate. The copper 2 will get reduced to become, the copper will get oxidized to become copper 2 plus. The nitrate will then become NO2. So that's why they say got possibility of brown gas forming. So that's how you're supposed to know. Now, this one is actually very hard to see. All 3, because they're all acid, they're all going to get effervescence. All 3 is going to get effervescence. And this one will be faster. So this one will react. That's why completely no magnesium react. This one got magnesium and magnesium. So the way it's going to work, right, is this one will tell you that it's actually ethanoic acid. This one will tell you that it reacts with the anion to give you the nitrogen dioxide. So this is the nitric acid. And this one, because it reacts faster, why? Because sulfuric acid got 2 hydrogen ions. Okay. You react faster, these 2 will be slower. So here we'll have some magnesium remaining. Here will not have any magnesium remaining. That's the idea behind it. Now, if you ask me, right, okay, this one I can accept lah. These 2 a bit iffy. You'll be very confused. How to differentiate whether is it nitric acid or sulfuric acid? I myself, if you ask me if I'm the one running this experiment, right, I will be very confused when you know. So I will do one simple experiment, one side experiment, an experiment that won't be recorded inside here, but it will confirm for me whether is it which one is sulfuric acid. Can all of you type in the chat group what would you do if you were me? Remember, all the table reagents are in front of you. There's one simple experiment that you can run, but no, you don't have to follow the experiment inside here. Just to straight confirm for you it's sulfuric acid. Can all of you please type in the group chat what's the one extra test that I will do? I won't follow exactly. I don't have to follow exactly the paper one. I can do one extra test if I want to. There's one simple experiment. Yes. I tell you, if I follow, I mean, I will record down all the observation now, just for the sake of, because it's all part of the points, right? But I tell you, if I go on like that, I'll be very confused. So straight away, just to double confirm more, FD6, right? What do? Straight away, all add barium nitrate. Straight away, all add barium nitrate. The one that give me white precipitate, done. We are done. Yes. Just add in the barium nitrate, just add in the extra barium nitrate, right? So if let's just say I do barium nitrate, right? The high chance is that here might form white PPT. Sorry. Here might form white PPT. But I know that because this time I'm telling you, if ever you have something like methanoic acid or whatever, diethyl acid, right? It can, only these two can oxidize up your propyl potassium manganate. So I know that high chance, this is the one. So this one straight away tell me it is sulfuric acid. So that's the idea where. Okay, now I want you guys to remind you, you must test the gas out for this one. You must test the gas out. But sir, you already know it's hydrogen gas, right? Because they're acid, they'll definitely react with metal, right? Okay, no time to test the gas out. Must write your test out. You must write your test out. Yeah, you no time to test the gas, it's okay. Okay, please write the test out. So anytime for any effervescence, right? I don't care what you do, write out the test. Even if no time to run the test, write out the test. Worst case scenario, wrong. Maybe it's not hydrogen gas. But if it's hydrogen gas, you get the 1 mark. Worst case scenario, you go and say, sir, sorry, I forgot. I forgot acid and metal reacts to form hydrogen gas. I thought acid and metal reacts to form carbon dioxide. You go and put gas turned lime water cloudy. Will they minus your marks? No, they will not minus your marks. They just won't give you this 1 mark only. So whenever write effervescence, don't care what you do. Always write in the gas. Just write the test out, even if no time to run the test. This one I'll leave it for you guys to figure it out. Now, this one, right, is hydrolyzed by heating up acid at FP7. Need to acidify first. This one now, we see the word halogen, you straight away know silver nitrate already. But this one, I just want to point out one thing before we do the aqueous ammonia, that one, right? There's one thing I'll point out. You need to acidify FP7 first, and I'll tell you why before you do it. Because the solution is full of hydroxide. What happens if you add silver nitrate? If don't acidify, will form white precipitate, which is silver hydroxide. That's why this one is very dangerous. This one is something I need to warn you about. So, when we see halogen atom, right, I want you to be careful because this one, I won't say much because it's very standard. It's standard as if you're asking you for a halide test. But because they go and put hydroxide, right, aqueous hydroxide, right? So what happens is that now the whole thing is full of hydroxide. If you go and straight away put in silver nitrate, the high chance is that you're going to form white precipitate. And then you'll be like, white precipitate, silver chloride. No, it's actually because you never remove the hydroxide, silver hydroxide. That's why a lot of times when the qualitative analysis notes, they often requires you to add in acid before you add in silver nitrate. Because if any hydroxide is inside the solution, you're going to get wrong data. We're going to get wrong data from white precipitate. Everybody okay here so far? If everybody okay here so far, please give a thumbs up. Oh, Justin add about 1 milliliter. 1 milliliter more than enough to reduce any away of the any acid. Please, please. When add acid to test for halogens, please don't add hydrochloric acid. Just add sulfuric or nitric acid. Why? Because you add hydrochloric acid, your Cl minus is you're gonna get white precipitate. Again, because of the Cl minus. So do take note of that.